So following on from our prior video, if we recall, we'd found this special class of odd binary numbers. It was this alternating sequence of ones and zeros, it kept going. In decimal, this sequence goes 5, 21, 85, and so on. And, if we recall these numbers, when we triple them, right, this is 10 and 5, we get this lovely interlacing behavior that in the 3n plus 1 step gives us a power of 2. So, after this, I was pretty pleased with myself, but I wanted to go further. I wanted to see what else there was. So what I'd really found was a class of numbers, a class of odd binary numbers that became a power of 2 after a single 3n plus 1 step, right? And so it's sort of natural at this point to be like, well, I've got this number n, put it in a box, 3n plus 1, out pops this power of 2, and then I know that these powers of 2 reduce to 1 under the Collatz conjecture. So maybe there's another number, I don't know, call it m, right, another class of numbers. We feed into the 3n plus 1, then they come out as some random number. They go into the n over 2, and they stay in there some number of times. And then we feed them back into the 3n plus 1 box a second time. And then this second time, out pops some power of 2, right? So you've got 1 Collatz odd step and 2 Collatz odd steps. So yeah, that was the next question I asked myself. Are there classes of numbers where, two steps through the odd Collatz function creates a power of 2? And the reason I'm focusing on the odd function right now is because if we look at our binary number, right, if we look at our even binary numbers, there were two classes, right? There were our powers of 2, which is 1 with some string of zeros after it. And then there was the other type, which is 1 followed by some interleaving pattern, and then all these zeros afterwards. And when we divide by 2, when we undertake the even step in the Collatz conjecture, the n over 2 step, and we strike off these zeros, we don't really change the pattern here, right? This pattern here is only impacted by the 3n plus 1 step. So if you take a number like 7, right, in decimal, which is 111 in binary, and then you perform that tripling step, right, you've got then you add your 1, and you're left with this new number that's like so. So this 1011 here, right, is very different from this 111 that was the initial pattern. It's grown, and we've split it. We've inserted a 0 in there. So the odd step in the Collatz conjecture, the way I was looking at it, sort of reshuffles these binary patterns. And so you know, I was sort of at this point asking myself, is there a way to find a general rule where we reshuffle these patterns, and we can show that every time we reshuffle these patterns, at some point we'll get some power of 2 after we perform this 3n plus 1 step. So I think this is a good place to stop here. And the next video will cover, a class of number that turns into a power of 2 after 2 binary or two odd steps through the Collatz function.